Hi! Fail fast, move forward. Incidents are a new normal. They're part of development process. And aware of that, become really prepared. We are seeing more and more software released to canary first. Feature flag adoption is growing. Monitoring and observability are our eyes and ears into turbulent reality of production. Industry leaders are showing us how to shorten feedback loop from production, how to set up proper alerting. We know that things are going to fail, but the only question is when. Maybe we will get notification about critical incident on a really important date. Maybe it will happen in the middle of night. I took this picture when my partner was 24 hours on call. And as you can see, he's not there. So as long as it happens rarely, it is okay. But what if it's happened often? What if you feel like you are playing in whack-a-mole, fixing one problem and seeing another similar popping a few days later? Is this game worth playing? I don't think so. So should we give up the idea of fail fast, move forward, and move back to enterprise waterfall process? I don't think so. And I'm going to show you how you can actually benefit from your incidents and learn more about your product, about your users, and about your organization. So my name is Kasia Szulc. I'm experienced incident facilitator, and in this presentation, I will show you how you can facilitate post-incident review. If you have any questions about post-mortems, about incident reviews, please ask them on chat. And why you should be interested in organizing incident review. Why it is valuable? Because software engineering isn't simple. And sometimes as engineers, we don't address the substance of the problem. Either because it is too difficult, because it requires us to get our comfort zone. And for instance, we need to make a change in the process. Or sometimes it's just easier to implement smaller fixes. Likely, they won't address the main problem at all, but at least implementation is easier. Before we start analyzing incidents, we need to remind ourselves that we are flawed and our software is bustling with life. And as engineers, we are just a small part of complex system. Often the way how our services, subsystem, or departments in our organization are interlinked with each other is hard to comprehend. So remember that one of the beautiful things about complexity is that we couldn't design it, even if we really wanted to. So if something so complex could be designed, it wouldn't be so complex. It would all have to fit inside the head of computer model, or maybe head of designer or design team. Complexity is not designed, and complexity just happens. Complexity grows and it grows more on itself, and it typically grows more. So that's why the single root cause of an incident doesn't exist. Systems can be made of many parts that in isolation, they work perfectly. Still, incidents could happen as a result of weird interaction between working parts, either software or maybe people or both. And we make our software relatively safe from single point of failure. But often serious incidents resemble a perfect storm where many bad events happen at the same time, making the whole situation even worse. But if we want to build a viable product, we need to care about our culture first. And there are 4 main elements of reliable culture. First is leadership. Without commitment from leadership, there is little point in trying to promote culture of reliability. If your leaders decide that developing new features is more important, then they will not support initiatives focused on reliability. They will push you into different directions. So they will not approve investment in improving how organization works. And reliability isn't something that single development can solve during hackathon. Reliability isn't built by running house engineering from time to time. And sometimes responsibilities of a team leader, including limiting work in process and eliminating roadblocks for the team, so they can get their work done without pressure. Reliability is not property of organization, but it is capability. It's like with Lean. You cannot say your organization is reliable by inspecting how it does at given time. You need to observe it over a period of time. The need of redundancy is the second ingredient. So the idea behind redundancy is that it is the only way to build a reliable system out of unreliable parts. Multiple and independent channels of communication and double checks should, at least in theory, to be able to produce highly reliable organization. Redundancy in high reliability theory can take two forms: duplication and overlap. In duplication, two different units or people or parts perform the same function, often in real time. Overlap is redundancy where units or people have some functional areas in common, but not all. So for example, we can have developers with SRE background to reduce time to react to incident. Decentralization and agility form third ingredient. High reliable organization, delegate and foster autonomy. Team members must be given the authority to make decisions that affect their work and their jobs, especially in areas where they are responsible for outcomes. So people have saying in the way they work, evolve their practices. And as a result, when incident happens, they don't wait for someone else to take over. They don't wait for SRE teams or for some DevOps team. They alone can assess severity and suggest remedy. Organizational learning is fourth ingredient for high reliable organization. High reliability grows out of incremental learning through experiments and errors. Things are attempted, new procedures or solutions are tested, and the effects are measured. Smaller dangers are courted in order to understand and forestall larger ones. Simulation and imagination are important ways of doing so when the cost of failure in the real system are too high. And for high reliability theory, such learning does not need to be centrally orchestrated. So after fire is done, we can start organizing incident review meeting. And some organizations use term post-mortem, but I will stick incident review because post-mortem means occurring after death, and it doesn't fit to our system. Because in majority of cases, our business or product will survive the incident. It will be still alive. And I really believe that we should normalize learning from incidents. So we have code review, design review, performance review, and KPI review. So we can have also incident review. Facilitators from outside of the team brings the fresh perspective. And this perspective is important because during incident, people do what makes sense to them at the time, given their experience, familiarity with process and tools, and their understanding of current situation. And facilitator who doesn't know what are the norms and procedures helps discover and understand how team perceive the world at the time of incident. So when team is responsible for analyzing an incident, they often are too focused on the incident itself. They talk about insufficient testing as the thing responsible for failure, and team is often so focused on the incident that they miss the context. And facilitator helps to uncover incident by asking open-ended questions, getting oral description from all involved. And those details are often in the form of tactic knowledge a facilitator helps to surface. So facilitator also helps people open up, get out of apathy caused by recurring failures and failed attempts in preventing them. And as facilitator, you need to be aware of two most common biases. The first is hindsight bias, also known as knew-it-all-alone effect. And hindsight bias refers to our tendency to overestimate in hindsight what one has known in foresight. In other words, it is all this, aha, I knew it, moments that you have on a daily basis, which were in fact just lucky strikes, and you wouldn't guess at all. In incident review, you can often find people who don't believe that analyzing incident brings value, because that was obvious that this service, this failure was gonna fail. And we should blame people who made that decision. We should blame product manager, project manager, or someone else. And we have tendency to overestimate in hindsight when one has no in foresight. The other important bias is availability bias. And as humans, when making decisions, we often have tendency to use information that comes to our minds quickly and easy. So if you invite only developers to incident review meeting, you will look at the problem from single perspective, from perspective of developers, and they will focus on on elements which are more familiar to them. So, for example, they will focus about architecture, about the problems with some libraries and similar problems. So if you want to be successful facilitator, the first step is to familiarize yourself with all perspectives. So as facilitator, it is important to invite people other than software engineers. Invite people who discovered issue, investigated issue, they fixed the problem, communicated issue externally, or other interested. Sometimes maybe that you can invite people from marketing because they are interested how they can use this incident to promotion. But you care about all those people because each perspective is unique and important, and you are in pursuit of objective truth. We are not looking to merge this multiple perspective in a single story. Quite opposite. The value is in multiple narratives. You look for contrast and things that complement each other. Another reason why you want to get as diverse crowd as possible, because each person is an expert in a specific domain. So once you're stuck digging and asking people about their daily practices, you will hear about the habits that they developed over time, about all the shortcuts, about checklists, and sometimes about their secret scripts. And you will hear about procedures that they follow, or sometimes they not. So we are looking for systematic improvements. We are not interested only in how developers work. And here is the hardest problem in tech. You have to talk to the people, and an incident review meeting needs to be blameless. Assume that every team and each member act with best intentions based on the information they had at the time. Instead of identifying whoever screwed up, focus on finding gaps in the process and correct them. Play the ball, not the player. Tell up the front, we have incident review, isn't to point fingers. Remind everyone that you are having incidents because you are successful. You have software that is running on production. You have paying customers and real users. And the reality is that sooner or later, you're gonna have incidents. You cannot avoid that, and you need to be prepared. Because failure is inevitable, success is elusive, and success isn't the absence of failure. It is the ability to cope with things that are changing rapidly and continuously. And in an incident review meeting, we don't talk only about why things went wrong, but also about how did things go right at the first place. And as facilitator, you don't want to look like you are FBI agent because it is not interrogation. It is just regular discussion and brainstorming. And the most important tool in your arsenal is empathy. Incidents are stressful enough. People believe that the actions they took, they were the best in the context they had. And this is called local rationality. No one really, no one wakes up in the morning thinking that the day change is going to cause an incident that will impact 80% of customers, or that they will take down production and Martin will have to fix it at 3 a.m. No, like everyone wants to perform a good job, be the best engineer and be the best expert. So when emotions run high and people start talking about actions using words like, if they only had, they could have, they failed, they should know, make pause in discussion, change topic, tell a joke about your biggest failure. In my case, it will be situation from last week where we deleted almost all our test environments by accident. So that's normal thing. And empathy can be really powerful to say, we are in this together and we can learn from this. And we don't want to discourage engineers from changing something in core element of our system. Quite the opposite. We want to empower them to take this risk. And once we gather individuals, we can start drafting a timeline of incidents. We want to build the context on incident by connecting all perspectives. So gather all facts or events or everything else related to incident. Identify cause and effect relationship and arrange them chronologically. If you work on small projects, then just grab Post-it and markers or use virtual boards like Miro, and together with your team, note down all the events. But if you work on complex projects, use a tool which generates a timeline from infrastructure perspective, like Dynatrace. This is screen from our incident analysis, and we are using this that we are copying this infrastructure perspective, and later we are adding the human layer with stick notes or into it. And timeline is really important. It's honestly the base, the foundation of incident review, because it helps to build common understanding of what had happened during the incident. It is not description of bug or fault. So it's a good idea to use additional data that may help to construct timeline, like chat transcription, dashboards, or logs that people observed during incident. And timeline is view on our organization, how it behaved before, during, and after incident. Timeline also helps to look at the incident from higher perspective, understand the perspective of people outside our tribe, and sometimes outside our company. The timeline doesn't need to be linear. When we have recurring events, it might be hard to represent it by single connection. For example, one of the events that led to Challenger and Discover disaster was the fact that in NASA, they've been using bullet points in reports. They have, this have been a result of local rational trade-off to increase efficiency in communication. But this bite-sized presentation collapsed data and conclusions. So it is more difficult to analyze them and find problems in them. Sometimes one timeline might not be enough for complex incidents where more than one department is involved or more than one application is involved or product. There are a lot of dependencies, and you can ask each part to create its own view on what happened in chronological order. Discussion over timeline are a great opportunity to discover stories behind incidents. And the questions you ask are key to encouraging discussions and making people to feel comfortable. Sometimes groups won't need to help to start discussion, and other groups, they will wait for direction from the facilitator. So it's good practice to have questions prepared in advance that may help start incident review. And even if you don't end up with needing them, the best facilitators encourage discussion through open-ended questions. So don't ask, Martin, when did you discover that this service is down? Instead of this, ask about how did you notice that something is broken? Because when you're facilitating, it is important to look for descriptions, not explanations. And sometimes people are afraid to tell what had happened because they are afraid your reaction. And they are trying to answer in ambiguous and defensive way. So it is important to catch those mysterious answers and try to dig a bit more. So, for example, if someone says, oh, yeah, it seemed a little off, you can ask about details and what specifically made you think that this seemed off. On the incident review, we don't talk only about the things that led to incident, but we also want to understand how things are usually going. So most of the times our systems work fine and we are prepared to fail. We use canary releases, feature flag, we test our solution before pushing into production. And I really love this meme that was created after YouTube was down last year. And I think this is like the true in one picture. So it is important to talk and share what we are doing to make our system bulletproof. We want to share those innovations and good practices beyond our team or product. When our timeline is done, we can start looking for causal factors. And causal factors are events or actions, or sometimes lack thereof, which led to the incident or worsen its effect. Causal factors are mistakes in process that led to the incident. They are either always or transiently present. Incident is just the first point in time where causal factors are combined into perfect storm. And causal factors alone, they don't cause big incidents. Not enough time for testing, not enough detailed monitoring. Those are examples of common causal factors. And suggesting those are key to understanding incidents is just misleading. Because we need to go deeper to find root causes. And root causes are everything that allow the mistake happen and to be ignored. The easiest way to find roots is to start with causal factors and go deeper with 5 whys or 5 hows technique. So let's imagine that our engineers detect a problem, they perform rollback to the previous version, and rollback didn't help, and they end up breaking stuff even more. So when you ask them why they tried the rollback, they'll tell you the story behind the procedure in case where the whole production is down. They describe sources of pressure, how they coordinated on call, so we can gather all those information about how this actually happened and what conditions allow it. So let's use the real example. We had the problem that log database hangs a service. So we can ask question about why database was locked, because that database was under heavy write load. Why this database was under heavy write load? Because nothing cut the extra load. Why nothing cut the extra load? Because we didn't expect the database to ever be compromised. And why we didn't expect database to can be compromised? Because we never done any stress test to find the limit. And why we didn't test it? Because our process doesn't require service owners to think about capacity and fallback. But there are few myths about 5 whys, and sometimes people say that this method, yeah, it's simple, but it's pretty useful. It's not useful, and there are I want to fight with those myths. So first is that 5 is too many or too few. So the 5 whys isn't meant to be literally 5 whys. Sometimes you will get answer with 3 whys, sometimes with 6. And the point here is to keep going and take deeper analysis of your cause and effect chain. The other myth is that there's rarely a single root cause. And yeah, this is true. There is no hard and fast rule that the answer to your final whys can be single cause. We often have the situation that the final whys is ended with 3 answers. So the goal here is to use the simple questions why to get the heart of what went wrong. And more complex problems might require additional approaches, but that doesn't negate the power of a simple strings of whys. And the last but not least, that 5 whys contributes to blame culture. One of the foundational rules of 5 whys is to never identify a person or people as the root cause. Human error, lack of employer X attention aren't acceptable answers to the question. What caused the human error? If you feel that why doesn't work for you, try to use house instead of it. Successfully minimizing consequences. We don't increase our success by trying to prevent things from going wrong. We do it by making sure that things go right. So quality and reliability are business concerns. And each time when we face the incident, we need to assess the risk and make decision. Can we handle the same incident twice? So when you discover a weak point in our process, we can think about how we can address it in the future and ask questions. How we can reduce the time it takes to identify similar problems. Or what can we do to reduce time it takes to resolve similar problems? Or what can we do to reduce the number of users affected? Or what can we do to eliminate similar problems from ever recurring? And we can define 2 types of action. First are corrective actions, where we know that problems may appear in the future. So we need to think about how we can improve detection or reduce the chance of occurring problem. And we can do this by improving our monitoring, improving our test strategy, or some other ways. The second type of actions are preventive actions, and their goal is to eliminate the cause of potential problems. So good action should meet requirements like proper action should be possible to finish at assumed time. For example, when our team came up with the idea that we should change totally our architecture and the microservices will solve all our problems. Is it good preventive action? No, it's only our wish. It is not possible to finish this action in 6 or 3 months. And also, decision about what we want to do must be our agreement. We need to get acceptance from our change funder. If we don't get approved from our team or business, we can have problem with realization of change and adding this action to roadmap. And finally, we should define who is the owner of action and who will be responsible for driving this change. It is important to remember that implementing action doesn't give us a warranty that our software won't fail in the future. It is important to monitor actions and check, does they work and what impact they have on the development process. Because fixing properties of a system that brought this failure into being may actually impact somewhere else at some other time. And this is the feature of complexity. Changing something in one corner can lead to vulnerabilities elsewhere. And this happens because making changes to some components in complex system affects other components. And power of complexity is that we can be really surprised how our software was impacted by really small changes. Once we had incidents resulting from not following migration process. So we decided that, okay, we will release all changes behind the feature flag. And this solution worked till the feature service went down and we started use caches, which weren't available on CAUSAL, so we couldn't scale up. And this is one of the features that makes complex system complex. The boundaries are fuzzy, and it is almost impossible to say where the system begins or ends and which part can be affected. So let's use our previous example with root cause that our process doesn't require service owners to think about capacity and fallback. For this cause, we can define actions like preventive actions that we can generate synthetic load on our staging, dog fooding environment. Or we can schedule a regular exercise for all service owners, determine that their service capacity at any given time. But we need some actions that we can just quickly be finished. So we can use corrective actions and configure monitoring for existing infrastructure. But there is the problem with action is that defining action is optional. In the past, I really believe that each incident review should finish with defining action that will prevent the occurrence of incident in the future. But the reality is that sometimes it's better decide that, yeah, we don't want to implement any actions. We are okay how our system works, and then declare action and just ignore them. The only mandatory action is share your learnings. If you learn something new from incidents, share it. Create Jira issue with description, write a blog post, organize a brown bag session, or just tell someone. If you think that something is obvious to everyone, it's not. And teaching is an incredible way of ensuring that you really understand what is happening. And building a learning organization is a real way to be proactive. That's how you actually prevent incidents. Because the reality is that your systems are failing. And anyone who says that failure is not an option, either is ignorant or arrogant of complexity. Because failure is an option, because we don't get to justify. It's going to happen. And if you are trying to prevent all failures, we would never move forward. We would miss a lot of learnings. And a lot of our knowledge from our systems comes from failures. And as said by Winston Churchill, never waste a good crisis. And we should never waste a good incident to improve your organization or our team or product. We need reliability, and we must adapt our systems to changes. And learning from gaps highlighted by incidents can guide the direction in which our system should evolve. Because incidents are new normal, but it doesn't mean that having constantly broken production is normal. We should build our software with quality and reliability in our mind. And in modern products where things change rapidly, failure is inevitable, and we strive to reduce the number of incidents of similar cause and await for unique problems. Thank you all, and I think we can go back to studio.